All right, so in our last lesson, we reviewed the law of sines and law of cosines that you learned in geometry, which we use to solve triangles that are not right triangles. So in order to find missing sides and missing angles in triangles that don't have a 90-degree angle, we can use that law of sines or law of cosines. Now, there's something a little bit different that happens with just the law of sines. We've got a couple learning goals for today. We need to be able to solve triangles using what we call the side-side angle case of law of sines. We also need to be able to recognize when the law of sines is going to give us no triangle or two triangles. So the reason why this is a special case, back in geometry, you used angle, angle, side, and angle, side, angle as two different ways to prove that two triangles were congruent. And the reason why you were allowed to use this is because there's only one possible triangle that can be formed. If I have a very specific sized angle, another very specific sized angle right next to it, and the side right after that, a specified length, there's only one way to connect the dots to form a triangle. Same thing with the angle, side, angle. If you hold those things constant, either angle, angle, side, or angle, side, angle, there's only one way to connect the pieces. So when we are using law of sines and we're given angle, angle, side, or angle, side, angle of a triangle, there's exactly one solution. And as you saw in yesterday's lesson in classwork, we didn't have any trouble solving those angle, angle, side, and angle, side, angle cases. Now, you also learned in geometry that side, side, angle was not a way to prove triangles congruent. And your geometry teacher may have showed you how multiple triangles could be possible and probably taught you to remember that the reason why side-side angle is not a way to prove triangles congruent is because if you read the letters backward, it spells a bad word. So you cannot use side-side angle as a way to prove triangles congruent. So sometimes, if you have two side measures and a given angle, it could form just one triangle. Sometimes there are two triangles that could be formed. Sometimes there's no possible way to connect the pieces in a triangle at all. Because there are so many possibilities, we call the side-side angle case the ambiguous case, because there are multiple possibilities. It's ambiguous. We're not sure what's going to happen. Now, there are rules that you could use to determine the solution. They're complicated. I don't memorize the rules at all. If you just love to memorize rules, I'm not even going to read the rules to you, but I did type them out here so that you could see that there is a method to the madness. But to try to memorize all of this, if it's obtuse and this is true, then it's this. If it's obtuse and the other is true, again, there's just lots of possibilities, and it's not something that I feel is worth memorizing. What I prefer to do is to just always assume that there are going to be two triangles. If there's just one triangle, in the process of trying to find the second one, you're going to get a triangle measure that doesn't make sense. For example, you might get a smallest angle that's not across from the smallest side, which you should know from geometry and the triangle inequality theorem that the smallest side in a triangle is always across from the smallest angle. The biggest side is always across from the largest angle. So you'll come up with something that doesn't make sense. If you assume that there are true triangles and there's no triangle, in the process of solving, your calculator will actually give you an error message. You'll get something that just doesn't work at all. So I'm going to illustrate these cases for you, so hopefully once we get done with these, you'll understand the difference. Again, if you just really love rules, have at it with the memorizing, but I just prefer to assume that there are two and then find out later that there aren't. Okay, so we're going to start the same way that we did with all of our other law of sines problems. First, I'm going to draw the picture because I need to know how the triangle is set up. So it says angle B is 33 degrees. So I'm going to draw something that kind of looks like a 33-degree angle to me. Again, the other ones, it's not really important what they look like. This is angle B. I'm making it 33 degrees. Side B should be across from angle B, and it says that that is 14. And then it says side C is 23. Again, it doesn't matter which side you make C, just as long as you label everything else appropriately. So let's say I make this C, which means that side C would be over here at 23, which means this would be angle A and this would be side A. So as we look at the triangle, we can see that this is a side-side angle. We know that because I have two sides in an angle, and the angle is not between. Remember that if it's between, that's side angle side. We use law of cosines for that. So this is a side-side angle case. So that means we're going to set up our law of sines to begin. So I start sine of angle B over side B equals sine, I don't know another angle, but the other side that I know is side C, so that means I need to use angle C. So here's my setup. I'm going to cross multiply 23 times the sine of 33 equals 14 times the sine of C. So in order to get C alone, first I'm going to divide by 14. So these cancel. So do 23 divided, or 23 sine of 33, and then divide that whole thing by 14. Should give you about 0.8948 as your sine. And again, just like we reviewed yesterday, when you're looking for the angle, that means you need to use inverse sine. So press second sine of 0.8948. Again, if it's already in your calculator, please don't round it. Just use your second answer button. That's going to give us angle C. So, angle C, when we solve using our calculator, we get 63.5 degrees. Now, when there are two triangles, and I said that the way I like to do this is to always assume that there are two triangles. And the way we find the other measure is by taking 180 minus the first one. So 180 minus 63.5. So angle C could also be 116.5 degrees. Now, you always have to check to make sure it's going to make sense. 116.5 plus 33 still leaves enough room for a third angle. So far, that seems to be working. So I need to continue with both of the triangles. These are a lot of work because you have to solve two totally separate instances. So if C is 63.5, then I can find side A by finding angle A. So I can do angle A equals 180 minus the two that I already know. So that would be the 33 I was given and the 63.5. So if C is 63.5, then A would be 83.5 degrees. I also need to solve this case. If angle C is 116.5, then I have to do 180 minus the sum of 33 and 116.5. So, in that case, angle A would be 30.5 degrees. So far, so good. Everything's making sense. Angle A is less than angle B. So we'll see if we get something that makes sense when we continue solving. So now I'm going to move on and find my last thing, which is side A. So I'm going to need law of sines there. So sine of 33 over 14 equals sine, in this case, 83.5 over side A. So cross multiply 14 sine of 83.5, and then I'm going to be dividing by the sine of 33 from the other side. That's going to give me my measure of A. This case, A is a side, so I don't have to do any inverses here. I get A is about 25.54. Now, I've finished one of the possible triangles, so I need to check to make sure it makes sense. The angles, I have 63.5, 83.5, and 33. A is the biggest, so A should be the biggest side. And if I look at the other two, 25.54 is bigger, so that makes sense. Angle C is the second biggest, so it should have the second biggest side, which it does. Angle B is the smallest, so it should have the smallest side, which it does. So this triangle makes sense. Now I need to solve the other one and make sure that it makes sense. So I do the same thing, sine of 33 over 14, but this time sine of this angle A possibility, so 30.5 over A. And again, do the same thing, cross multiply 14 sine of 30.5 this time, divided by the sine of 33. It's going to give us A, which in this case would be 13.05. So check this triangle. C is the biggest here, so 23 is bigger than 14 and bigger than 13.05, so that works. B is bigger than A, so 14 should be bigger than A, which it is. So these all work, so I'm going to go ahead and get all of my answers. So there's my C's. Here's my A angle. And here is my A side. So I always get disappointed when there are two triangles because it's a lot more work to do the two triangles. All right, so let's start the next one. Again, draw yourself a picture. Here A is 79 degrees, so almost 80 degrees. So I'm going to label this A, make this 79 degrees. Side A is across from it at 16. Then it says side C is 9. Again, it's not going to always be drawn to scale, but this one looks smaller, so I'm going to choose that one to be my side C, which means this is angle C, which means this is angle B, and this is side B. All right, so let's set it up. Law of sines, so angle and the side that are paired together, start it. So sine of 79 over 16 equals, I have another side. This is a side-side angle. So the 9 goes on the bottom, that's side C, so angle C is what goes here. So cross multiply, 9 times the sine of 79, and I'm going to be dividing that by 16 to get the sine of angle C. So when I press this in my calculator, I get angle C to be about 33.5. Once we do that, we assume two triangles. We say or angle C equals 180 minus 33.5, which means angle C would be about 146.5. Now here's where common sense has to come into play, and sometimes some of you write down some answers that don't make any sense. So let's think about this. If angle C is 146 and angle A is 79, and the total of a triangle has to be 180 degrees, then there's something wrong, because 79 plus 146.5 is already over 180. So that doesn't work. So that means that we get to cross out our second triangle possibility because it doesn't work. It doesn't give us anything that makes sense. So at this point, you have to show that you checked it, that you tried the second triangle and that it didn't work. That's part of the work that I'll be checking when you get to your test to make sure that you are trying to find the other possibility if there is one. So The possibility doesn't work, so that means I just continue solving with what I have. So if angle C is 33.5, then I find angle B by taking 180, subtract the 2 that I already have, so 79 plus 33.5, which means angle B is about 67.5 degrees. So we already had C. Here's angle B. So the only thing left to find is side B. So law of sines, sine of 79 over 16 equals sine of 67.5 over B. So cross multiply, 16 sine of 67.5 divided by the sine of 79 is going to give me B. So when I multiply and divide, you should get B as about 15.06. Always check to make sure it makes sense. We know the angle measure is added to 180. A is the biggest, so side A should be the biggest, which it is. 16 is bigger than 15. Then side B and angle B should be the next biggest, which they are. And then side C and angle C should be the smallest, which they are. So it all makes sense. There are my missing sides. All right, last but not least, let's draw ourselves a triangle here. Oh, that does not look like a triangle. It's not really looking like a line, but oh well. Angle C, 63 degrees. Side C, 8. Side B, 11. So we'll make this B, we'll make this A, side A. So we do have side-side angle, so that means law of sines, ambiguous case. So sine of 63 over 8 equals sine of B over 11. Cross multiply 11 times the sine of 63 and divide it by 8 is going to give us the sine of angle B. So 11 sine of 63 divided by 8, you should get about 1.225 for the sine of B. So then you do inverse sine, because when we're looking for the angle, we use the inverse. So inverse sine of 1.225 will give us the measure of angle B. And when you press that in, your calculator says error, which means these are our favorite, that there is no triangle. It's not possible to have this as a sine value, which means that given these three measures in that order, if you were to cut out sides that are 11 inches long and 8 inches long and a 63-degree angle, that there would be no possible way to fit the triangle together in this order. So that just means that there is no triangle. And that's a fact, Jack.